Okay, guys, so after our last 2 days of charting stars by their luminosity and magnitude, we're going to talk about the Hertzsprung-Russell diagram, which is more commonly known as the HR diagram. So let's talk about how stars are classified. Stars can be classified in 3 ways. They can be classified by their size, and we kind of already touched on this in the life cycle of a star, by how massive they are. Are they giants? Are they average? Are they dwarfs? Are they supergiants? Stars can also be classified by their temperature, and the star's color reveals its temperature. Red stars tend to be the coolest temperature, where blue stars tend to be the hottest temperature. And then the last way that we classify them is by their magnitude, which is their luminosity and how bright they are. It is the amount of light a star gives off depending on its size and temperature. Now, you should know that by the way you've charted them, blue stars tend to be the brightest. However, if a star is really big, like a supergiant, it's obviously going to give off more magnitude than a dwarf. So make sure you know the 3 ways that we classify stars: size, temperature, and magnitude. So let's talk about magnitude. How bright a star looks from Earth depends both on how far the star is from Earth and how bright it actually is. A star's brightness can be described in 2 ways. There is apparent magnitude and absolute magnitude. Now you need to make sure that you understand the difference between the two. Apparent magnitude is how bright the star looks from Earth. When you go out at night and you're looking at the stars, how bright does it look? That is its apparent magnitude. Absolute magnitude is how bright the star actually is. Okay, so definitely write those 2 definitions in your C notes. So, absolute magnitude is the actual brightness of a star, which is our perspective from Earth, has nothing to do with it. Astronomers compare the brightness of all the stars to the brightness of our closest star, which is the sun. So, for example, let's look at this picture right here on A and B. Okay? If you had to choose between the two, which one would you say is closer? Well, from Earth's perspective, they actually look like they are the exact same distance, exact same magnitude. But in reality, A is a lot bigger and brighter, but it is farther away compared to B. So from Earth, they look the same. So that's why scientists always go with absolute magnitude opposed to apparent magnitude, because things aren't always as they appear, right? So let's look at this first one. Which star appears brightest from Earth? Would you say it is A, B, or C? Now, from Earth. Well, you would say C, because it is the biggest, so therefore it's going to give off the most light and be the brightest. On the second one, which star actually is the brightest? Which one is it's absolutely the brightest? Well, the answer is B, because it's the biggest. So now, let's look at this one. Here's a tricky one. Which star is the furthest from Earth? A, B, or C? Well, the answer is B, because again, it is the biggest, so it's the furthest from Earth. So let's get to the meat of it. The HR diagram, remember, which stands for Hertzsprung-Russell, which are just the 2 scientists who invented this chart. An HR diagram shows the 2 most important characteristics of a star: their temperature and their absolute magnitude, which is the exact same as luminosity. Scientists plot the surface temperatures of star and their brightness on a graph, just like you see over here on the right-hand side. And if you notice, that should look very similar to what you did. You took some stars, you took their luminosity, you took their temperature in Kelvin, and you plotted them. And this is exactly what the HR diagram does. And it breaks the stars into different categories of their life cycle. So, the main sequence. Okay? We know that this is where a star spends the majority of their life. The main sequence are this band of diagonal stars that is always going to start in the top left and move at a negative slope to the bottom right. Well, you probably are thinking, well, mine was different from that. Well, notice that on the bottom, on the x-axis, they have the highest temperature on the left and the lowest temperature on the right. Now, why do they do this? I'm not sure, but this is how the HR diagram is. So this is the main sequence. And if you'll follow, notice at the top where the star is the hottest, because it's right here on the left, and the brightest, it's blue. And as you follow through the diagonal band, you can see it become blue-white, white, yellow-white, yellow, orange, and red. So as the star gets older, what happens to its temperature? Well, it decreases. As the star gets older, what happens to its luminosity? It dims. So both are having a negative effect. That's why it is a negative slope. Okay, so just remember, as a star gets older, it loses its temperature and cools off, and it loses its brightness. So this is the main sequence. So our sun is probably right around here in the main sequence because it's yellow. Okay. So now here's another picture. I'm just going to show you all of these. I know that the HR diagram is going to be on the star test because it's a chart, but we have no idea how it's going to look. Notice you still see the main sequence going from the top right to the bottom left. But now there should be some other areas. There's this section right here of white dwarfs, which remember is the leftover core of an average sized star after it explodes through a planetary nebula. There's giants, and then there's supergiants. So here's a dumb way to remember, but it's hilarious. Okay, so our white dwarfs, they are our supermodels, if you will. So just follow my analogy, okay? They are really, really hot, but they're not very bright, okay? Then when you get up here to our supergiants, these are our nerds. They're really, really bright, but they're not very hot, okay? And then main sequence, like everybody wants to be a blue star, right? In the main sequence, because if you're a blue star in the main sequence, you are really hot and really bright. But nobody wants to be a red star or a red dwarf because they're not hot and they're not bright. They're like the D-to-Ds. Okay? So I know it's a dumb analogy, but it will always help you remember. So why are the supergiants up so high in the luminosity? Well, even though they're red and they're not very hot, they're really bright because they're so big. And then giants are a little bit dimmer than the supergiants, but brighter than the main sequence because, again, they're bigger. So according to the HR diagram, you should be able to figure out what color a star is based on its temperature, the size of it based on where it is on the HR diagram, and its luminosity. If they're in the top left, they're hot and bright. If they're in the bottom right, they're cool and dim. If they're at the top right, they're bright but not hot. And if they're in the bottom left, they're hot but not bright. Okay? So just here's another picture of the HR diagram. Again, sometimes they actually color the stars, like on this one. Sometimes they just color the background and plot the stars on it. It doesn't matter. All HR diagrams plot stars by their two most important characteristics, temperature and luminosity. So if you're going to look, here's the sun. Okay, here's Betelgeuse. Here's Polaris, the North Star. All right, so these are just examples of all the stars that are around us in the galaxy. Okay, so what I want you to actually do is, which one would you say is the easiest? This one? No, we'll do this one. Okay, I want you to pause the video and I want you to draw this in your journal. And if you're towards the end of your page on your C notes, just flip it over and make the whole page an HR diagram because I am going to take this up for a grade. So yes, before you even argue, you have to have color, but you don't need to color the whole background black. That's just pointless. So make sure that you do have the luminosity on the Y, temperature on the X, but remember the difference from yours. We have increasing moving to decreasing. And that you you don't need to draw every single star. Just kind of draw a narrow band with a bunch of circles in it, but do kind of show the color changing. Make a white dwarf section, a giant section, and a supergiant section. Okay, so pause the video, draw in your HR diagram, and I will check it first thing in class tomorrow. Thank you.